Hello everyone. Today our topic is ideal voltage source and the practical voltage source. So first of all we will see what is an ideal voltage source. So from the definition you can see it has the zero internal resistance and it delivers the energy at a specified voltage which does not depend on the current delivered by the source. So let us first plot the circuit diagram. In this circuit diagram, here the input voltage source is your Vs. Okay, and here there is no internal resistance, so R is 0 here. So if you will apply the KVL, that is Kirchhoff's voltage law here, so I can write for this circuit I can write this is Vs minus V, that is equal to 0. Now here we can write V will be equal to Vs, that is the output voltage will be equal to the input voltage that we have applied. Since here there is no internal resistance, in case of the ideal voltage source there is no internal resistance here. Now if we will plot a graph between the voltage and the current, so here this Vs represents the input voltage, so we will get a straight line, because when you will increase the value of the current, here you can see if I will increase the value of the current here, I will get the same voltage over here. We will get the same voltage across the output. So in case of the ideal voltage source, since there is no internal resistance, here we can say the output voltage that we will get, that is this voltage V, it will not depend on the current. That is, if you will increase the amount of current, you will get the same output voltage, that is your V, or the same Vs. Okay. Now we will see what is the practical voltage source. In case of the practical voltage source, it has a finite internal resistance. Okay, you can see here it has a finite internal resistance and it delivers the energy at a specified voltage which depends on the current delivered by the source. So here you can see the difference between the ideal voltage source and the practical voltage source. Here we will get a finite internal resistance will be connected in a circuit, and now the value of the current, that is when you will change the value of the current, then definitely the voltage will be different. Now let us see the circuit diagram here. So you can see here the internal resistance here is Rs and Vs is the input voltage. So that here you can see the current I is flowing through the resistance Rs. Now here if I will apply the KVL, that is the Kirchhoff's voltage law, here we can write Vs, you can see that is Vs minus this is your IRs minus I into Rs, that is the potential drop across the resistor, that is IRs, and again this is your minus V, and that is equal to 0. Here we have applied the KVL, and now we can write the output voltage V will be equal to this is your Vs minus IRs. This is our total voltage, that is the output voltage. V will be equal to Vs minus IRs. Now from this expression you can see that here this value of V, it depends on the value of the current I. That is, if I will increase the value of the current I, that is suppose the value of current I increases, then definitely the value of IRs it will increase. Then I can write IRs also increases. Now we can write this is your V equal to Vs minus IRs. When the value of the IRs will increases, then definitely the value of V will decreases. Okay. Since the value of the current increases, then definitely I into Rs will increase. And we are subtracting this IRs from this Vs. Vs is nothing but your input voltage. So when we will subtract this term, that is IRs term, from this input voltage Vs, then definitely you will get a lower term. So that you can write this is your V whose value decreases. Now if you will plot a graph between the V and I, so let us here plot the graph, that is suppose here this axis is your V and here the axis is your current axis. So suppose the input voltage is here the Vs. Okay. Now the current is suppose at this point I, and you know when the value of the current increases I, when the value of the current increases, then the value of the V decreases. You can see here I can draw like this. Okay. Now you can compare the ideal voltage source and the practical voltage source. In case of the ideal voltage source, the value of V, that is your V, that is the output voltage, remains constant, whereas in case of the practical voltage source, the output voltage value will decrease, because here you have connected some internal resistance Rs, but in case of the ideal voltage source, the internal resistance is 0. So this is all for today. In the next class we will see what is ideal current source and what is practical current source.